Hey guys, Mr. Holman here. For this week, we're going to move on to our second lesson in rational expressions. And this week, it's going to be multiplying and dividing rational expressions, which really is going to build off of what we did last week fairly well. So if you had an easy time with the lesson last week, this week will probably be fairly similar for you. So let's take a look here at when we multiply fractions. Remember that the main way that you can multiply fractions is to multiply the numbers across both the numerator and the denominator. So in this first example, we would take the 3 times 8 and the 7 times 3 to get 24 over 21. Of course, we want to make sure that anytime we multiply fractions, we always want to reduce at the end. So in this case, the 24 over 21 is actually going to reduce back to the 8 over 7. And that would be our final answer. But as you have gone through math, you probably learned that there might be another way that we could do this. And instead of multiplying across the numerator and denominator, you might instead say, well, I have 3 in the top and bottom of the fraction. So what I'm going to do is I'm going to cancel those out so that I get 1 times 8 over 7 times 1. That arrives at the same answer, 8 over 7. And in this case, it saves us the time of multiplying and then canceling again anyways. So what we're going to do is we're going to take this same idea and we're going to apply it now to multiplying rational expressions. That is, multiplying fractions that have polynomials. The first thing we would want to do is remind ourselves that when we're looking to cancel things out, we can only cancel factors, which means if I have a quantity of x plus 2, I want to put parentheses around those things. So that's what I'm going to do first. Then, since they're common between the numerator and denominator, I'm going to cancel those out. The other factors we can cancel in the numerator and the denominator are the two x's. I can't cancel the 2 and I can't cancel the 3 as the coefficients, but I can reduce those x's. So now what we really have in this case is 1 times 2 over 3 times 1, and that's going to simplify for us eventually here. Sorry, I recorded the video and I'm narrating it separately to try and cut down on talking and jumbling. It's going to give us 2/3. All right, so there's our final answer. One of the things that you want to make sure that you remember, and I said it already, we can only cancel out factors, not terms, which means if I have a binomial, x plus 2, I can only cancel out that whole quantity if I also have that same quantity in the denominator of the fraction. So now let's look at some examples. Here we have in number 4, 2a squared d over 3bc times 9b squared c over 16ad squared. This would be a case where we're multiplying two monomials together. And in this case, when we're canceling, we don't have to worry so much about quantities because there's really only one expression in the top and bottom of both fractions. So instead, we're going to look at what are some things that we can cancel or reduce. And I typically look and see first at the coefficients. Can I reduce the coefficients of the expressions? Then I would look at, can I reduce the variables somehow? So in this case, we're going to reduce the 9 over 3 to 3 over 1. And we're also going to reduce the 2 over 16 to 1 over 8. Next, I would look at my variables. And for the variables, what we're going to do is we're going to use our exponent rules. And that means we're going to cancel out the smaller exponent term for like bases. And we're going to subtract the smaller exponent from the larger exponent on that like base. So if we go through here, I would cancel the a and subtract 1 from the a squared in the numerator. I'm going to cancel out the b in the denominator and subtract 1 from the b squared in the numerator. The c's are the same, so they cancel out completely. And then with the d, we're going to do the same thing. We're going to cancel out the numerator, and we're going to subtract 1 from d squared in the denominator. So now, if I look at everything that I have left in the first fraction, I have 1a over 1. I'm going to multiply that by the 3b over 8d. And at this point, what we should notice is that we don't have anything else that can be simplified or reduced. We have canceled all those terms already, so we're saving ourselves the work of having to do that later. And instead, we're just going to combine the numerator into one larger monomial and make it 3ab, and our denominator is simply going to remain as 8d. Nothing to cancel out. That would be our final answer. With monomials, it's really more of an exponents type problem that we did earlier in the year and that you did last year in Algebra 1. Now we're going to move on to an example where we actually have larger polynomials. So here you can see we have x plus 5 over 3x times 12x cubed over x squared plus 7x plus 10. And one of the things I'm going to do is first, I'm going to put my parentheses around the x plus 5 to remind myself I have to be able to cancel out that whole quantity. But when I look, I don't see anything that cancels. That's because we have to recall from last week, before we simplify, we want to make sure that we factor first. So the x plus 5 and the 3x, I can't simplify anything there. The 12x cubed is fine. It's the x squared plus 7x plus 10 that we need to factor. And in this case, quadratic trinomial means that we're going to factor that using reverse FOIL so that we get x plus 5 times x plus 2. And if you're doing these problems correctly, again, most of the time you're going to end up with something that should cancel in both the numerator and the denominator. So here, since we have the x plus 5 in both the top and the bottom of the fraction, they're going to cancel each other out. We can also reduce the 12 over 3 to 4 over 1. And I'm also going to cancel out my x's that are outside of the parentheses because those are factors. So my first fraction, I've really canceled out everything there, and it's 1 over 1. The second fraction, we have 4x squared in our numerator. In our denominator, we canceled out the x plus 5, so we just have the x plus 2, which really means when I multiply by 1 over 1, it's going to remain as 4x squared over x plus 2. Remember, when we have these solutions where we have a binomial by itself in the denominator, you don't have to rewrite the parentheses. You can leave it just as the x plus 2 without the grouping symbols. I want you to try number 6 here on your own. So you can see the problem there. It's n minus 4 over n minus 2 squared times n squared minus 4 over n squared minus 3n minus 4. So if you want to pause for a second, remember you want to factor the expressions, especially in the second fraction. And then we want to look at what are the common quantities that we can cancel out. So go ahead, try this one on your own. All right, so now what we're going to do is we're going to look at what you should have factored. So if we take a look here, and again, I'm going to note that you should factor this first. We're going to leave the first fraction as n minus 4 in the numerator, and I'm actually going to take the n minus 2 squared, and I'm going to rewrite that as n minus 2 times n minus 2. And you're going to see why as soon as I factor the second fraction. Because the n squared minus 4 is a difference of squares, so that becomes n plus 2 times n minus 2 in the numerator. In the denominator, n squared minus 3n minus 4 is a quadratic trinomial, so we're going to reverse FOIL it into n minus 4 times n plus 1. So now we're looking at what are the common quantities that we have between the tops and bottoms of both fractions. And we see that in the first fraction, we have n minus 4 in the numerator, and we have n minus 4 in the denominator of the second fraction. So those are going to cancel out. I also have n minus 2 in the denominator of the first fraction, and actually I have 2 of them. But remember, I have to be able to pair them up to cancel them. So I'm going to cancel one of those with the n minus 2 in the numerator of the second fraction. But that first fraction, I cannot get rid of the n minus 2 in the denominator. So what I'm going to be left with in this case is 1 over n minus 2 times the quantity of n plus 2 over n plus 1. And now what I'm going to do is I'm going to multiply those two fractions together. In the top of the fraction, we're going to have n plus 2. And in the denominator, I'm going to leave it as n minus 2 times n plus 1. Although technically, you will see in some cases, some people will redistribute, and they'll make it n plus 2 over n squared minus n minus 2. But in most cases, I'm going to leave my answer in that first answer form because that is my factored form. And that's actually the preferred form because we took the time to already break things down. Just like we did last week, we said we're breaking something down. We don't necessarily want to go ahead and redistribute, undoing the work that we just did. So the factored form is probably going to be preferred. All right, and now we're at number 7. Here we have 3x squared minus 9x over x minus 2 divided by x squared minus 9 over 4x minus 8. And we're going to make 2 notes here. First, we still want to make sure that we factor first before we try and simplify anything. Otherwise, things aren't going to cancel out. The second thing here is the key that now we are dividing these. And you might remember that we do not divide fractions. Instead, what we're going to do is we're going to take this and we're going to change it. Because in general, if I have a fraction divided by a fraction, say a over b divided by c over d, instead what we're going to do is we're going to take that and we're going to change it into a multiplication problem. We're going to take the a over b and leave the first fraction the way it is, but we're going to multiply by the reciprocal of the second fraction. So we're going to multiply by d over c. And that applies to these types of fractions as well. So what we're going to do is I'm actually going to combine the factoring and the change to multiplication all in one step. If you want to try this one on your own, I would suggest factoring the first fraction and then change it to multiplication, flip the fraction and factor them, and then let's see where we get. So go ahead, try this one on your own, hit pause, and when you're ready, pick it back up. All right, so let's see. When you factor the first fraction in the numerator, you have a GCF of 3x, and that's going to leave us with x minus 3. X minus 2 we can't do anything with in the denominator. Then we're going to multiply. And as I said, we're going to flip the fraction, and I'm going to factor it. So I'm going to take the numerator, which should now be 4x minus 8. I'm going to factor that into 4 times x minus 2. In the denominator, x squared minus 9 is a difference of squared roots. That becomes x plus 3 times x minus 3. So now we're looking at what are some common factors we can cancel out between the numerators and denominators. And in this case, there should be 2 of them. We can cancel out, as we see here, the x minus 2's in the denominator and numerator. We can cancel out the x minus 3's. The 3x times 4, we can't cancel those out because they're both in the top of the fraction. So that's going to be multiplied. And the x plus 3 is being multiplied by 1. So that's going to stay in our denominator. We will simplify the 3x times 4 to 12x because that would be simplest form. But we're just going to leave it as 12x over x plus 3. That would be our final answer. All right, so multiplying, dividing rational expressions, as you can see, is really just factoring and basically simplifying rational expressions between 2 different fractions. Rules haven't changed from last week. If you have any questions after watching this video, let me know. Otherwise, I will see you at our Zoom conference on Wednesday. And you want to check the rest of the agenda for your assignments. Again, this week we'll have an IXL topic for practice as well as another graded worksheet. So thanks for watching. Good luck, and I'll catch you guys later.